Good day, grade 10 learners. Welcome to our first live lesson for Term 2. I am Sikhulile Ncube. This lesson is proudly brought to you by the Gauteng Department of Education. Right, are you ready for the lesson, grade 10s? I hope so. Right, let's make sure that we have our things ready for the lesson. Please have your books in front of you. You are going to be writing today. We're going to be writing, we're going to be doing activities. Please don't just sit there. Make sure your book is there. You even wrote the date. The topic is trigonometry, and we're doing trigonometric ratios. You can write the topic for today. Let's do that. Let's be ready for the lesson. We're going to be starting now. Are we ready? Please remember the WhatsApp line 064-748-8913. Remember the WhatsApp line. You are free to ask questions. We have a team this side. We're waiting for your questions. Very, very important. Questions are very, very important. We have to interact. Okay? All right. If you want, you may send us your work. We really appreciate that. We want to see if you're doing your work. But please ask questions. At the end of the lesson, you should be understanding everything that we are going to discuss. Okay? Can we start? All right. Let's start. Okay? So trigonometry in real life. Some of you are saying, why do I start trigonometry? What is this? Why should I start mathematics? Mathematics is very, very important. Okay, right. Trigonometry is the study of relationships between the sides and angles of a triangle and the calculations based on them. Trigonometry is applied in real life. Okay, let me show you some of the things where trigonometry is applied. So these calculations are used in areas like surveying, okay, navigation. Have you heard about these things? Okay, please check about them. Aviation, satellite systems, you see, satellite systems, astronomy, land surveying, okay, and cartography, drawing of maps. Trigonometry is used in all those things. ETC, it means here we have not exhausted the things where trigonometry is applied. So it is very, very important for us to understand what? Trigonometry. Let me give you a simple illustration of how trigonometry is important, okay? Right, I'm going to give you, there's a popular building in Johannesburg. Do you know it? If you see the picture, you know the building. Okay, let me show you. It's called Ponte Building. Okay, have you ever seen this building? Okay, now, can we measure the height of this building? Who's going to take the tape measure and start climbing this building and measuring? You see? But as mathematicians, we can apply trigonometry to measure the height of this building without climbing it. Do you know that? So you just have to measure the horizontal height. You are on the ground. You are standing on the ground. You measure your distance on the ground between you and the building. And then there are instruments that we can use to measure the angle. In this case, it will be angle of elevation, right? So there are instruments that we use to measure the angles. We can even create our own instruments. Do you know that? Using a protractor. Very simple to create. Okay, one day I will show you. Right, then we measure the angle. We measure the angle. You see, now using this angle and the horizontal distance, applying trigonometry, we can calculate the height of this building. Do you know that? So do you see how we can use a trigonometry? Right, I'll show you how we do these calculations using trigonometry, okay? So that is trigonometry in real life, okay? Right, now let's go to our objectives. By the end of this lesson, you should be able to define trigonometric ratios. It's your first time in grade 10, you've done your school from primary up to grade 9. I think it's first time now to do sine theta, ne? Right, we are going to look at sine theta, that's a trigonometric ratio, cos theta, tan theta. Today we are understanding these three trigonometric ratios. Okay, right, can refer to the CAPS document, page 23. Right, grade 8 and 9, we did triangles. We did specific type of a triangle called right angled. What is a right angle? Grade 10s, what is a right angle? Please, can you answer the questions? You can shout the questions there or raise your hand and give your answer. What is a right angle? It's a 90-degree angle. 90-degree angle. So right angle triangles have a 90-degree angle, okay? And then we did the Pythagoras Theorem, okay? Right, now, before we move any further, I want you to name these three triangles. I'm going to give you 2 minutes. And then after 2 minutes, we're going to mark our work. Right, 2 minutes, let's name the triangles. Okay, let's mark our work grade 10th. I hope you managed to write the correct names of the triangles. Right, we are giving answers and doing corrections at the same time, okay? As we give the answers, mark your work. If it is wrong, correct there and there, okay? Right, the first triangle, triangle ABC, what is it? What type of a triangle is that? It is an isosceles triangle. Why is it an isosceles triangle? Because we have two sides. Side AB is equal to side AC. Okay, you see that the two sides are equal. Remember, a triangle has 3 sides. When the 2 sides are equal, then the triangle is what? It's an isosceles triangle. Again, we can say that the 2 angles are equal. So for an isosceles triangle, angles opposite equal sides are equal, or sides opposite equal angles are equal. Remember that, okay? Then the next triangle, what is the name of that triangle? It is a right angle triangle. Where is this name right angle coming from? It's coming from the right angle, the 90-degree angle. This symbol here that you see here means 90-degree angle. Okay, so this is a right angle triangle. Our trigonometry today is based on this one, on the right angle triangle. Okay, and then we have the third triangle. What type of triangle is that? It's a scalene triangle. It's a scalene triangle. If you check this side, is different from this one, is different from this one. All the 3 sides are different. Even the angles, you can say this angle is not the same as this angle. It's not the same as this angle. So the angles also are different. So that's a scalene triangle. Okay. Right. For this one, the next one, I want you to give your answer there. Just give it verbally. You don't need to write it down. What is the name of this triangle? What is the name of this triangle? It's an equilateral triangle. Okay. All the angles are equal. 60, 60, 60, which is 180. And then all the sides also are equal. That's an equilateral triangle. Please remember that. So those are type of triangles we're going to deal with. Later on in the other lessons, we're going to use the equilateral triangle somehow. And then we're going to use also the right angle triangle. Okay, when we want to prove the special angles. Right now, we are continuing with our activity. Given the angle triangle APC, sorry, the right angle triangle APC, okay, at angle B, the right angle is there. AP is 5 units and BC is 7 units. Calculate the length of AC. So AP, let's write our information. AP is 5 units and then BC is 7 units. Let's calculate the angle, sorry, let's calculate the length of AC. I'm going to give you 2 minutes to do that. Let's try. Welcome back, returns. I really hope you're doing your work. Are you doing your work? Okay, please remember WhatsApp line 064 748 8913. Right, let's do it together and we're going to be marking our work. Now, how can we find the side AC? How can we find the side AC? There is a theorem that we've been doing since grade 8, right, about what? Right angle triangles. What's the name of that theorem? It is the Pythagoras Theorem. Okay, what does it say? In terms of triangle ABC, our side AC is the hypotenuse. How do I see the hypotenuse? How do you see that AC is the hypotenuse? From here, you can see it is the longest side. Okay, but sometimes it may look, using the longest side, sometimes later on you may find that it may not be sort of perfect. Right, the perfect thing to use that the hypotenuse is opposite the right angle. Identify the hypotenuse by seeing what? The right angle. So the hypotenuse is opposite the right angle. So AC is the hypotenuse there. So we're saying, according to the Pythagoras theorem, AC squared is equals to what? AB squared. Do you remember that? Plus what? Plus BC squared. Okay. And then why are we saying AC squared plus AP squared? Sorry, why are we saying AC squared is equal to AP squared plus BC squared? Why are you saying that? Because of the Pythagoras theorem. Pythagoras theorem. So remember, we always write our reasons. We are saying this because of Pythagoras theorem. Okay. Now we can substitute our things. So AC squared is equals to 5 squared plus 7 squared. Okay, right, we want to find AC. What can we do? What do we do, Cretans? We square root both sides. If you want, you can find what this thing is. 5 squared plus 7 squared, that is 74, isn't it? But you can even say AC, I'm square rooting both sides here. Okay, let me show you so that, okay, square rooting both sides. I'm square rooting both sides like this. Do you see that? And then square root and the square, they cancel each other out. We remain with AC is equal to square root of 74. Okay, so it means AC is square root of 74. Okay, how many people got that? Do you have this statement with your reason? Did you substitute correctly? Do you have your square root of 74? Okay, all right, let's move on. Next one, you must get it. Okay, next one, you must get it. Now, same thing now, but take note, AC now is 5. AB now is 4. We are finding BC. Okay, can I give you a hint? The Pythagoras theorem does not change. The Pythagoras theorem does not change. Let's find BC. 2 minutes. Welcome back, returns. Did you manage to get the answer? Remember, the Pythagoras theorem does not change. So we're saying AC squared is equals to AB squared plus what? Plus BC squared. Why are we saying that? Because of the Pythagoras. Pythagoras. Okay. Do you see that? Now, the Pythagoras theorem does not change. Now, let's substitute. So it's going to be 5 squared is equals to 4 squared plus BC squared. You see, I haven't changed anything. And then now I can transpose. Remember that? And it becomes 5 squared minus 4 squared is equals to BC squared. And then what is 25 minus 16 is 9 is equals to BC squared. Then we square root both sides. Square root. 3 is equals to BC. Remember, square root is plus or negative 3, but this is distance, so we're taking 3. Right, so this is 3. Remember that, okay? Right, this one, you must know this combination of 3, 4, and 5, okay? Just remember that for Pythagoras theorem. Right, let's move on. Right, given the right angle triangle ABC with reference angle, it means our reference point is angle alpha. Which side is the hypotenuse? Which side is opposite angle alpha? This angle that I've circled here. Which side is adjacent next to angle alpha? Now you're naming your sides like, is it AC? Is it AP? Is it BC? Okay, let's name. I'm going to give you 1 minute so that we can move on. 1 minute, then after that we discuss our answers. Let's try. Right, welcome back, grade 10s. Remember, when you are marking our work, you are doing corrections at the same time. You can even maybe correct with your pencil, okay? Right, now, hypotenuse. Which side is the hypotenuse? Is it AC? Is it AP? Is it BC? The hypotenuse is AC. The hypotenuse is AC. The side opposite the right angle. The side opposite the right angle. Which side is opposite the angle alpha? Okay, this side, going this side. So side AB is opposite angle alpha, right? And then which side is next to? Adjacent means next to, right? Adjacent, this is just next to the angle there, which is BC. You see that? So BC is adjacent to angle alpha. So we are going to be using these three things a lot today: the hypotenuse, the opposite side, and the adjacent side. Okay? The hypotenuse, the opposite side, and the adjacent side. Now we're getting into our trigonometric ratios now. Okay? Right, now, you may find angles named by means of Greek letters. You see, I was saying angle alpha now. Some of you are saying, is that alpha? Is that A? Right, so these are some of the symbols you may find in mathematics being used for angles. Okay? It's not like every angle is angle theta. I'm going to be using angle theta today, but it can be named alpha, it can be named beta, it can be named x, it can be named a, it can be named according to the vertices of the triangle. So now, but if you see this, this means theta. This symbol is theta. Some of you are doing physical sciences, you have seen these symbols, theta, and then this one is beta. If you see this, when I'm saying beta, I mean that. When then alpha, I mean that. So you may find these letters in our trigonometry. Okay? Right. Now, naming the sides of a triangle. When angle alpha is the reference angle, let me try to explain this. We have done the activity. Let me try to explain this. I'll give you the activities to do. Right. When angle alpha is the when alpha is the reference angle, this is our angle, because the opposite side, the adjacent side, will depend on the angle that you are referring to. Okay? Now, the hypotenuse is very clear. It is the side opposite the 90-degree angle. So this is the hypotenuse. Right? Some people say this thing is forming an arrow there to point. You see? It's pointing towards the hypotenuse. Okay? And then this is the opposite side. Oh, sorry, the adjacent side. BC is next to the angle. You see? When you're looking at the angle alpha, BC is the adjacent side. And then AB is opposite on the other side. Let's look at another angle. Let's say now angle theta is our reference. We had alpha here. Let me write alpha here. Right. And then we have theta there. Still, the hypotenuse is the side opposite the right angle, isn't it? What is the adjacent side? If you look at angle theta, please, can you give your answers verbally? What is the adjacent side? The side next to angle theta. This is the theta. Which side is next to that angle? It is AP. Okay, AP is next to angle theta. So which side is opposite angle theta? It is, so let me show you the AP, just next to. And then BC is opposite angle theta. So now, but if you check, AB was opposite angle alpha. AB was opposite angle alpha. When I'm saying alpha, I'm talking about this one. But when you look at the angle theta, it's now adjacent to angle theta. You see that? So it is very, very important to check which angle are you referring to. And then you identify the side. Okay? So now you're going to be applying that in today's lesson. And I want you to get everything correct. Let's see. For angle ABC, now I'm introducing the ratios now. And I want you to write this down. Write it down. The ratio opposite over hypotenuse is called the sine of angle theta. This ratio is called sine of angle theta. Please write that down. 1 minute. 1 minute, write it down. The ratio over hypotenuse is called the sine of angle theta. Very good, grade 10s. We are getting, these are our ratios now. Okay, let's name this one ratio number 1. Let's name it ratio 1. Maybe we can just put 1 next to it. Ratio number 1. Opposite over hypotenuse. Opposite side over hypotenuse side will give us our ratio. It is called sine of angle theta. That's ratio number 1. Let's go to ratio number 2. We're doing 3 ratios. Right. The ratio adjacent over hypotenuse is called cosine of angle theta. The ratio adjacent over hypotenuse is called cosine of angle theta. Let's write it. Ratio number 2. Okay, 1 minute. Copy that. Right. Let's go to our ratio number 3. I hope you've copied these 2 ratios. The last one. The ratio opposite over adjacent. The ratio opposite over adjacent is called the tangent of angle theta. Is called the tangent of angle theta. Let's copy our ratio number 3. The opposite over adjacent is called tangent theta. 1 minute. Right, welcome back. Now we have our 3 trigonometric ratios, cretans. Okay. Do you know these 3 trigonometric ratios? Sine of angle theta is opposite over hypotenuse. Cosine of angle theta is adjacent over hypotenuse. Tangent of angle theta is opposite over adjacent. You are going to know it, don't worry. It's about this today. It's about this topic today. Right, now, I said name them ratio 1, ratio 2, ratio 3, okay? Right, now, so we say that the ratio opposite over hypotenuse is called sine of angle theta, isn't it? So like if this is angle theta, we'll say this side AB, okay, is AB over AC. That is sine of angle theta. Okay, so we don't usually write the whole thing, sine of angle theta. How do we write it? We say sine theta equals opposite over hypotenuse. Next to ratio number 1. Can you write this thing that I've circled here? Right. Next to ratio number 1, say sine theta is equals to opposite over hypotenuse. Just op over hypo is fine. Okay. So this is how we write it in mathematics. We say sine theta. So now I don't want to see this mistake where people just write sine equals opposite over hypotenuse. Some people say sin equals opposite over hypotenuse. There's nothing like that. It must be complete. Is sine of angle theta, is sine of angle A, is sine of angle X. So it should be sine theta, not just sine or sin. There's nothing like that in mathematics. Okay? Right, next to ratio number 1, can you copy this? I'm not going to go away and this time, just 30 seconds is enough. Copy this, write it next to ratio number 1. Sine theta equals opposite over hypotenuse. Sine theta equals to opposite over hypotenuse. That's how we write it in mathematics. You have copied that, should be fine by now. Let's move on. Ratio number 2, what did we say? We said that the ratio adjacent over hypotenuse is called cosine of angle theta. Cosine of angle theta. So we call it what? Cos theta. Cos theta. Next to ratio number 2, can you write this? Cos theta. Next to ratio number 2, write that. Cos theta is equal to adjacent over hypotenuse. Arch over hyp is still fine. Okay? You see that? So we cannot say cos and end there because it's meaningless. Cosine of what? Because cos theta means cosine of angle theta, cosine of angle X, cosine of angle alpha, cosine of angle A. So it must be cos angle, sine angle. Okay, right, copy that. 30 seconds is enough. Let's try. Next to ratio number 2, cos theta is equal to adjacent over hypotenuse. Right, cos theta is adjacent over hypotenuse. Thank you very much. I hope you're done. Let's move on to the third ratio. What did we say the third ratio is? Tangent of angle theta is what over what? It's adjacent side over hypotenuse side. These are ratios, not angles, ratios. Okay? Side over another side. So it's adjacent over cosine tangent of angle theta. We said opposite over adjacent. Okay, opposite over adjacent. So said tangent of angle theta is opposite over adjacent. So how do we call it in mathematics? Do we write the whole thing tangent of angle theta? How do we write it? Do you want to try? We say tan theta. Okay, good. Tan theta. Tan theta is opposite over adjacent. Next to our ratio number 3, write that. Tan theta is adjacent, opposite over adjacent. I'm making this mistake. There's something that I must use that will make sure that I don't make this mistake. Do you know that? Okay, I'm going to give you a very, very common acronym that we use in mathematics. Okay, I've heard some people even making songs about this acronym. It's a very, very common acronym. Okay, it's called SOHCAHTOA. This will help you a lot in grade 10. If you're doing trigonometry, just write this acronym first. It will assist you a lot. Even now, I use it. You see, I was making mistakes. I was saying tangent, adjacent over opposite, which is wrong, isn't it? But now if I write this, I won't make that mistake. Write this acronym, SOHCAHTOA, in capital letters. Okay, just copy this. This is the acronym I'm talking about. SOHCAHTOA. Write it down. 30 seconds will be enough. Okay, I'll write it by the side here. If I finish, it means also you have finished. Okay, that's SOHCAHTOA. Yeah, I'm done. Everyone is done. Done now. Everyone is done. Okay, SOHCAHTOA. Right now, what does this mean? How will this assist us? How will this assist us? So the first one, the S there is for sine theta. Sine theta is equals to opposite over hypotenuse. Don't forget that. Sine theta is equals to opposite over hypotenuse. Don't write these things. I'm just showing you. You can write by the side. Sine theta equals to opposite over hypotenuse. You can write like that, okay? Instead of drawing funny things around your SOHCAHTOA. Leave your SOHCAHTOA what? Clean. Leave it clean and write by the side. Sine theta is opposite over hypotenuse. Okay? You see? You write this, you won't go wrong. Let's go to the next one. What will you say? Cos theta. Cos theta is adjacent over hypotenuse. Cos theta is adjacent over hypotenuse. Okay, let me go back a bit. Right, cos theta. I'm using theta. It's not every time we're using theta for angles, isn't it? Cos theta is adjacent over hypotenuse. Right, and then tangent of angle theta, which is tan theta, is what? Tan theta is equals to opposite over adjacent. Okay, opposite over adjacent. Please copy this, and then after that we go to our activities. Okay, right, done. So these are the 3 trig ratios, grade 10s. We are not going to forget this. We are not going to forget these grade 10s. Right, SOHCAHTOA, sine theta is opposite over hypotenuse. Cos theta is adjacent over hypotenuse. Tan theta is opposite over adjacent. I don't know how many times I've repeated this, so you can't forget this. You can't forget this. Right. So I will do the first 3. Okay. Right. If you want to try to be ahead of me, please do so. I'll do the first 3, and then I'll give you the next 3 after that. Okay. Right. But if you think you can manage to do things faster than me, can you try to do that? Let me give you time to copy this triangle. Can I give you 1 minute? Right, even you can write the question if you want, but just the triangle is enough. Then we're going to write our ratios. Right, copy the triangle for 1 minute. simenza move fast 20 minutes. So ngabe sithi babonise activity, okay, bese siya ku right. Welcome back, grade 10s. Welcome back. Are you happy? Okay. I want you to learn. I want you to enjoy the lesson. Please don't forget 064-748-8913. Okay. Right. Now, because of time, I wanted to give you things to try. I'll do the first one, then you do the next one, like that, okay? But if you can be ahead of me, you can do so. Right, sine theta. Okay, let me write my soccer tour. Tour. Okay, where's my angle theta? Is here. Sine theta, opposite over hypotenuse. Which side is opposite angle theta? Is AB. Hypotenuse is AC. You see that? Opposite over hypotenuse. Cos theta, I'm still looking at cos theta here. Adjacent over hypotenuse. Which side is adjacent to angle theta? BC. Which side is the hypotenuse? AC. You see that? Okay? Doesn't take time, isn't it? Let's be careful. It's not all about angle theta. Beta. Now I'm looking at this angle here. Tangent of angle beta is opposite over adjacent. You see that? So which one is opposite? This one, BC. Which one is adjacent to angle beta? Is this one, AB. So it's going to be BC over AB. You see that? Didn't take time. Right, let's mark our work. Now, let's mark our work. We said that was our triangle there. This diagram is repeating. Okay, let's go back. Right, let's mark our work using this. Okay? Right, okay. Right, I'll go to the next one. First, let me leave this slide. Yes, this one is nice. Right, I'm going to give you 2 minutes. I want you to try this one for 2 minutes, and then after that, we'll mark our work. Find sine beta, cos beta, and tan theta. Let's do that for 2 minutes. Welcome back, returns. Welcome back. Right, remember WhatsApp line 064 748 8913. Okay, send us your questions. Right, let's mark our work. Did you manage to get it? Soccer tour. Soccer tour. Right, let's mark our work. Now, let me write it down. Soccer tour. Okay, right. Sine beta. Where is beta? It's here. I have to check my reference angle because this thing changed. If I'm referring to sine beta and theta and beta, the opposite and adjacent sides are not the same. So I'm looking at sine beta now. Okay, sine beta opposite over hypotenuse. The opposite side for sine beta is BC. You see? That's BC. The hypotenuse is AB. Hypotenuse is opposite the right angle. Okay, so opposite over hypotenuse will be BC over AB. Okay, mark that. Let's go to cos beta. Let's look at cos beta. Right, which side is adjacent next to? It can't be AB. Why not AB? Because AB is the hypotenuse, isn't it? So now this is the adjacent side. AC is the adjacent side, and then AB is the hypotenuse. So now it's going to be adjacent over hypotenuse, AC over AB. Mark that. Okay. And then we have tan theta. We have tan theta. Now, be careful. Which angle are you referring to? Now, tan theta is opposite over adjacent. Opposite over adjacent. Which side is opposite? Angle theta is AC. Which side is adjacent? It can be AB. AB is the hypotenuse. So it's this one, BC. So tan theta is AC over BC. Okay? Right. AC over BC. Let's mark our work. I want to give you 1 minute to look at this work and make corrections if you have to. If you need to ask maybe say or ma'am there or even your colleagues, you can do so for 1 minute. Let's try. Right. Welcome back, great hands. Did you manage to do your work? Did you get everything correct? Well done. Well done. Well done. Let's move on. Right now, it's still the same thing. It's still the same thing, but you may find things represented differently. Okay, in mathematics. So now, I want us to look at how we name the sides of a triangle so that you know which side is opposite, which side is adjacent, which side is hypotenuse. Okay, because we don't use AB, BC, CB every time. Okay, sometimes we may need to use the sides like this. Okay, so how do we name this side of a triangle? So we're saying side opposite angle A is named with the small letter A. You see, this is side angle A there, small letter A. You see that? So the side opposite angle A is named with small letter A. And then the side opposite angle B, please don't write this, it's fine, I'm just reminding you. Right, side opposite angle B is named with small letter B. You see this? Okay, side opposite angle B is named with small letter B. And then side with angle C, opposite angle C is named with small letter C. Okay, so in the next example now, I'll be using the sides as using the small letters to name the sides. Okay, but same thing. Okay, right? So I've got two more questions. I'll explain them, then we go to our last question. Okay, right now, but if you want to be ahead of me, please do so. Consider the following diagram and then answer the questions that follow. State the following in terms of R, P, or Q. So now let me go straight to the answers. Right, what would be sine alpha? This is alpha here, right? SOHCAHTOA. Okay, right, sine alpha is opposite over hypotenuse. The side opposite angle alpha is R. The hypotenuse is Q. Do you see that? So I'll say R over Q. Okay, try cos alpha ahead of me fast before I say the answer. Cos alpha, write it down. Okay, right, good. Right, cos alpha is adjacent over hypotenuse. Let's look at angle alpha here. Adjacent is P, hypotenuse is Q. So cos alpha is P over Q. Okay, mark that if you got it. Let's go to tan beta, angle beta now. Tan beta first. Tan beta. Tan beta. The tangent is opposite over adjacent. Opposite is P, adjacent is R. Do you see that? So it's going to be P over R. Did you get it right? Okay. Right, good. Right, let's move on to the next one. Let's try to utilize the few minutes that you are left with. Okay. Right, I'm tempted to give you just 1 minute to try. Can you try this one for 1 minute? And then after that, I'll come back and then I explain the rest. Just 1 minute. Right, welcome back. I'm sorry they gave you a short time, but there's nothing we can do. I hope you managed to utilize the 1 minute. So sine beta, SOHCAHTOA, just remember to write it till you get used to it, okay? SOHCAHTOA. Right, sine beta, opposite over hypotenuse is P over Q. Okay, mark that. And then cos beta is adjacent over hypotenuse, so it's R over Q. Mark that. Then tan alpha, please be careful there. We're talking about alpha now. Tan alpha is opposite over adjacent, so it's going to be R over P. Okay, mark that. Okay, well done. Now let's do our last activity. Right. I'll try to. The 1 minute that I'm giving you is not that I want you to finish everything. I want you to be ahead of me. Okay, because we're left with 5 minutes. So I'm going to give you 1 minute to be ahead of me. After 1 minute, I will start explaining everything. Okay, right. Don't do everything, just be ahead of me. Okay, for 1 minute. Let's try. Right, welcome back, grade 10s. Okay, we've thought of giving you another minute so that you can try this. It's not about you listening, it's about you trying, okay? We'll finish in time. So I want you to concentrate on A, and then after doing A, and then we'll go to B together, C together. But now let me give you another minute so that you can finish A. Let's try to do A for another minute. Right, welcome back. So let's try to get the length of DF. What type of a triangle is DEF? It's a right angle triangle. It's a right angle triangle. So we can say DF squared is equals to 5 squared plus 12 squared. Why are we saying that? Because of the Pythagoras theorem. Please mark that. Right, now let's find what DF is. We square root both sides. So DF is going to be 13 centimeters. Okay, so we use centimeters here, but we're told that these are units. So it will be fine to say 13 units. Okay, 13 units. And then we put our 13 there. Okay, did you get that correctly? Good. Now, we asked to do the 3 ratios. Okay, we've been doing this. So let's do it together. Let's do it together and then we'll be fine. Right, what will be sine theta? 5 over 13. Do we agree? Theta is here. It's opposite over hypotenuse. So it's 5 over 13. Okay. Right, cos theta. Try to be ahead of me. Cos theta. What is cos theta? What is cos theta? It is going to be, or it is 12 over 13 cos theta adjacent over hypotenuse. Okay, 12 over 13. Okay, good. And then what is tan theta? Oh, I gave you the answer there. What is tan theta? Tan theta is opposite over adjacent. So what is it going to be? It's going to be 5 over 12. 5 over 12. Good. Okay, let's go to the next one for angle beta now. Angle beta, what would be sine beta? You can even say it even without writing it down. Say it. What is sine beta? Opposite over hypotenuse. Which side is opposite sine beta is here, and then hypotenuse is this one. So is 12 over 13, that's sine beta, 12 over 13. Do you agree? Okay, just say your answers. Don't write them down. Okay, and then what is cos beta? Cos beta, grade 10s. Cos beta is going to be adjacent over hypotenuse. So it's 13 over, adjacent over hypotenuse is 5 over 13. 5 over 13 for cos beta adjacent is this one. And then hypotenuse is 13 there. And then tan beta is 12 over 5 because beta there, the opposite is this. And then the adjacent is 5 there. So it's 12 over 5. Okay. Did you learn something today? I really hope so. And then if it was revision, also now you understand this. You mustn't lose marks on the trigonometric ratios. So these are our 3 trigonometric ratios. SOHCAHTOA. Remember that. Okay? Right. Now, after this, I'll be checking some of your WhatsApp questions, then I'll be answering you. Okay? Right. So let's just, the homework. Please, let's have 1 minute to copy the diagram. Just copy the diagram, don't write. And then you know what I want from you? I want the sine theta, the cos theta, and the tan theta from it. Okay, just copy the diagram. You know I want what? The three trigonometric ratios, the three of them. Just 1 minute. Welcome back, grade 10s. I really hope that you learned something. I'm so happy, grade 10s, to be here in front of you with the dedicated team this side. We really appreciate being in front of you and teaching you. Please continue doing your work, and we're going to meet in our next lesson. But before we go, let's just summarize our lesson. Remember, I'll be checking your WhatsApp questions after the lesson. Okay, right? And then we say that sine theta is opposite over hypotenuse. Sine theta is opposite of hypotenuse. Don't forget that, grade 10s. Are you going to forget that? And then we said cos theta is adjacent of hypotenuse. No one is going to forget that. And then tan theta is opposite of adjacent. And we have our most common acronym, which is SOHCAHTOA. Use that a lot and you'll never go wrong. Let's meet in our next lesson, grade 10s. Thank you very much. Have a nice day.